What's up guys, welcome to the third video in Be a Java Engineer. My name is QD Yazdani and you guys watching my channel Koraiwood. As we already mentioned that this Java course is for beginners. So if you're a beginner, you can take advantage of this. You can learn computer architecture, but if you're more advanced, you can recall the computer architecture knowledge. This video is very beneficial for those of you that are not aware with the computer architecture, and you guys want to know about the computer architecture, how the computer architecture works. And in the next video we're going to see the platform independent and platform dependency, how this one works, and this all going to help you understand how Java works with the Java virtual machine. So we begin with the computer architecture. What is computer architecture? A computer system is made up of all the components that are necessary for a computer to operate and the connections between those components. There are two basic categories of components. We have hardware and software. So a computer system that you guys can see in front of you as a computer system, because we all computer programmers, is made of a lot of components. And all of these components are connected to each other. And the basic categories, that there are two basic categories of components. There is a hardware and software. So what is hardware and software? Hardware is something that you can touch, and software is something that you can see. With the hardware you can see too, but the hardware, say for example, any parts of the computer that you can touch, for example keyboard, CPU, etc, whatever, etc, mouse, you can see that the monitor, you can see the CPU, RAM, whatever you guys see, that's called hardware. That's very hard. Software that programs or apps running inside the computer, say for example Windows, Mac, iOS, Linux, Google, Yahoo, Facebook, whatever that runs inside your computer hardware, that's a software. So there are two basic categories of the components, and we call this a hardware. Is something that you can poke it with the stick, that's called hardware, and something that you can't poke it with the stick, say for example app, or something that provides service to you, or interacts inside the computer monitor, is called software. Alright, now we're gonna see the internals of the computer, how the computer architecture works, and are the different components of the computer architecture. CPU. First we begin with the CPU. What is CPU? CPU is the brain of the computer. It executes codes and makes everything happen. Whatever you guys gonna see, you guys interact with the computer, because you guys need to interact with the brain. And what is the brain of the computer? And that's CPU, central processing unit. We have a hard drive, and we call it hard disk as well. And what is the hard drives? They store data just about permanently. Within a hard drive you'll find tens of thousands of files, whether they're pictures or they're text files or database. So whatever you guys store in your computer, you guys store your files. Say whatever you guys working with your IDE or the source code, or pictures or videos, video and pictures of your loved ones or your friends, family, whatever you guys upload, or yourself, your own photos, that goes into hard drives. And video card, it displays all of the computer's images, photos and videos. And keep in mind, video cards are very important if you guys are looking for say images or photos, and if you guys want to render videos. And if you have a very powerful video card, you can play all sorts of games. And if you see nowadays, a lot of our laptops are especially made up for games, because they have a very powerful media files or video card. So RAM is called random access memory. When running any types of the software, computer uses RAM to execute it from. Switching off computer will clear out your RAM. So RAM, computer uses for random access. Say for example, your temporary files goes there. Sometimes things like all these computers, sometimes they don't need, they put it there. Sometimes your computer needs something, they put it there. It means that's a random access memory the computer uses for temporary, or sometimes computer uses not for permanently. For example, sometimes you guys typing your assignment or something, a computer puts inside the RAM, and once you say for example save it, press the save button, it goes there, and then it goes into the hard drive, and the computer manages this random access memory. And the last one is we're going to see the motherboard. What is a motherboard? Motherboard creates a working computer and is connected to CPU, HD, VC and RAM. So everything, whatever we see on the top, we see the hard drive, we see the video card, we see the RAM, the CPU, everything is connected to the motherboard. That's why it's called mother and board, because it's a mother of everything. So the RAM is there, it's like a board, but it has a RAM, it has a video card, it has a hard drive, it has a CPU, everything it has. Alright, so now we're going to see or whatever we have learned so far, we're going to see in pictures. As before we mentioned that we're going to show you with the picture. This is how I found it to make it things like quicker. I found it for hardware video images for the hardware, and you can see this is the images for the hardware. Whatever you guys can touch, that's the hardware. So that's how the examples the hardware, and you guys can see. And as I said, here you can touch the hardware. You can open you can see the different architectures of the hardware. So this is the hardware of the computer, where you can see the wires, you can see the guys fixing the hardware, and you can see this is the best example. You can see there is a CPU here, there is a monitor here, there is a keyboard here, and there is a little piggy bank here, and you can see all the whole trash of the hardware, and you can see the internals of the computer hardware. Alright, so next we're gonna see the CPU, and this is the CPU. That's the brain of the computer. This is the heart of the computer. And you see that CPUs, some of the chips have Intel written on it, because Intel is the biggest company. They are the first company who made this CPU, and you can see there is a chip here, and what's inside this one, if you guys wondering what's inside all of this chip, are these ones, transistors. One transistor by itself can't do anything. You need millions and hundreds of thousands and or millions or billions of the transistors to make the magic happen. Just like neurons, you need in the human body there are billions of neurons, and they can provide like say sensation or feelings or whatever emotions, whatever you can think of, and they connect every parts of your body to the brain, and brain to the body, or every cell they connect it to the brain. So brain have all the information. They get all the information through the neurons in our human body, and say if you're from your toe all the way to your fingers, all the way to 5 fingers, from one hand 5 fingers another hand, and they send information around the clock 24/7, every seconds, every milliseconds of the time. They send every information, every time of bit of changes inside the body. They say the brain gets information, and if there is some problem, then the brain starts working appropriately to fix up the problem. Same with the computer needs the more you provide it, the better it is, the best it makes the chip stronger. The first Intel, they come in, they put the CPU here. That's the heart of the computer. That was a 4-bit, so they make it 8-bit, then they make it 16-bit. I think that was 16-bit that I have learned. So that was Intel 16-bit 8085 that I have learned the assembly language. So in a bit inside here there is a registry, and the first thing that I have learned, that was register organization, Intel registration organization of 8085. There's a memory inside here with all these transistors and all the machine codes. So if you look in here, that's the main memory, that's the memory of the computer. So the whatever you guys going to see, the transistors are stored here. Say for example, nowadays there is Apple i7, for example. The mobile phone have a billion of some phones, they have a 16 billion, some of them they have 20 billion transistors, some of them they have 30 billion, some of them 80 billion transistors, 80 billions of this. And keep in mind there is something called Moore's law. What Moore's law, they say is that because this transistor was very expensive at the old times when the Intel started, like almost $2 or something. Then after a while, this, because there was a mass production, it becomes $1 or something. Say here $1.49 something, and then it becomes like $1.20, then becomes $1, then becomes 95 cents, then it becomes 80 cents. As the time passed by, because there was more and more demand for transistors, it became like 80 cents. Then as the prices of this one came down, the computers become cheaper and cheaper, and the memory becomes widely available. And the Intel co-founder calls Moore, his name was Moore, he put a law. He says the more you guys the transistor getting cheaper and cheaper, the computer is getting stronger and stronger and faster. So his theory was proven to be true, and as we know today is called Moore's law. So the Moore's law says that as the time goes by, the computer is going to get cheaper and cheaper, and the computer memory is going to get cheaper and cheaper. So back in 1950s or 1955s or 1960s, you guys could not imagine 1 megabytes or even 1 gigabytes of their data. There was unimaginable. So the computers has to bring the 5 megabytes of data for like $25 million, and they had to bring with the plane, because at that time the computer was at the size of the whole big room. So it was take the whole room just for one computer, and the people come in and manually they flip zeros and one, because inside this one there are zeros and ones. It's called binary. So binary is 0 or 1 inside. So inside all the computer understands 0 and 1. We call this one as machine code. Okay, so as I said to you guys, then according to Moore's law, it becomes cheaper and cheaper till today, that you guys can find like 500 gigabytes of hard drive plus 8 gigabytes of random access memory for say $300. But at that time, that was if you would say, people would laugh at you. And then even if you say, because in 1980s that was very, very hard to imagine, like even 5 gigabytes computer or something like that. That time it was kilobyte, it was byte and kilobyte. All right, so nowadays this is computers like become very cheap and widely available. Everyone have access to computer, and there was a faster mobile phones. And as I said to you guys, like Apple, inside the Apple core, inside the Apple the brain, the main memory of the Apple, there are like billions of this one, 16 billion transistor, because this widely is so cheap. It becomes like, according to Moore's law, like I said, in the old time it was very expensive, but now it's becomes like, after that becomes like 80 cents, become 50 cents, then becomes 10 cents, then become 5 cents, then become 1 cent, and now maybe you can find a lot of this. Maybe now the companies can buy mass, because a lot of companies produce this, so this is very cheap now, and the companies can afford to put millions and billions of this transistor inside, can store inside one of this main memory, or inside one of this chip. So this is the main memory of the computer, and we're gonna come on inside the hard drive. If you look in here, it looks like a disk. It looks like a normal disk. Every time you guys store something, then it goes down and it stores something on here, same like a disk. You guys store the optical disc, DVD or something. You guys want to play your favorite song or something song, you guys can do that, and that's how it looks. The hard drive looks from outside. And this one, if you have an old computer, you can go there, open your CPU, and you can take this one out. You can take this one out. You can put a few wires, and there was a software which can recover all your data, old data. Say if your parents' computer, you can take this one out. You don't need to take the cover out. You don't need to take this cover out, but you guys need to put some sort of power here. There is a USB here. Then you when you put a USB, connect the USB to your computer, and when you go and buy that USB, make sure you tell that computer store that you're looking for to recover the memory from your hard drive. Then they know what sort of, give you what sort of USB, that USB goes here. Same works inside the computer, because computer there are wires comes and connects to this one, and it goes to the and displays the memory, because all your memories comes here, because that's why it's called hard drive, or this is the black box of the computer. And you guys can take out this one, power it, connect it with your computer, and you can recover all your old and valuable data. Say for example your parents for example, data, or they have photos of your grandparents or your parents, which was like 30 years old or 40 years old photos. You can recover from this hard drive, as I did to my computers. I went there, bought the USB, and that USB goes one end here and one in my computer, and I use a special software to recover the data, and I recover all the data from the hard drive. You can do that because your data is here permanent. Keep in mind, but as soon as you guys connect this one, you guys needs to run the antivirus software, so scan this storage. This is going to be same as C inside the computer, so you make sure you guys do that, because some of these hardwares, because it sits there for a long time, they still have viruses inside. Okay, so that's a hard drive. And now we're going to come to video card, and you look in here, there's a video card. Some of these video cards is one of the best in the world. Nvidia, HP, XFX, AMD, there are a lot of video cards that you can find, and they're putting inside the hardware, inside your operating system. Some of these ones are very expensive, and some of them is very fast. So this one's, if you look in here, this video card of the computer, I think this one's Nvidia. So some of them is Nvidia or Nvidia, whatever you guys see. This one's very expensive. This one's for I think gaming. When it comes for gaming, these video cards are very expensive. Some of them you can find like some of this computer equipped with this one, maybe 3,000 or 4,000 computers just for gaming, because they have a very powerful video cards. And this video card goes inside your computer, and you can render the videos, images, everything, whatever. If you have a problem with this video card, then your videos get very blurry and you guys can play game or something, then you guys need to change this one. Okay, this is a random access memory. It goes on the computer too, and as I said, there are different types of this random access memory. It's like 2 megabytes, some of them 2 gigabytes, some of them 1 gigabyte, depends how much money you want to spend. As if you guys can, if you have a computer, you guys can go on computer store and you can increase this one like this. You can increase this one. So for example, if you're getting 2 gigabytes, you can put it here. You can put it and you can increase it in the, if you can buy it yourself, and you can increase it yourself too. Say if you buy random access memory like this, sometimes it comes in 2 gigabytes, sometimes some of this comes into 4 gigabytes, and you can put it like this inside the computer, and you can increase it that way. And the final ones, this is a random access memory. The final one is motherboard, and the final ones here, the motherboard. This is the motherboard. This is where everything, all the whatever you guys see in here. You guys see in here the transistor goes here inside this one. This one process zeros and ones, the binary, and keep in mind the binary is all 0 is 1 is called machine code. The computer understands zeros and ones inside here. And this one's here is a hard drive, your video card, your random access memory, everything goes here. Whatever you guys can think of, looking here, all of them's here. All of them's one by one, side by side. They put it here, assemble it, and you guys gonna have the big motherboard. Some motherboards very powerful, and some motherboards very small. And as the time goes by, it gets more sophisticated, more and more sophisticated, and with more and more powerful. So, and nowadays you guys buy it off the shelves inside the stores. You guys just go there, walk in, and you guys going to see the motherboards lying around everywhere. You guys can buy it. Some of them is like very cheap. Raspberry Pi is very cheap. You can bring it and you can install it yourself. You can do that. And some of them is very expensive. And if, say for example, you guys can replace this one as well yourself. So we as a computer programmer needs to know all of these motherboards, all of this random access memory, say video card, we have a hard drive, we have a chip, and we have a transistor. Knowing understanding of this transistor very essential part of the computer programming. So if you want to be Java engineer, you guys need to understand this transistor, and this transistor goes inside the main memory. And the main memories, there's different main memories inside the Intel. The first one that I learned there was the register organization of 8085. Inside the register, they have a machine. We have a machine language, and we have a hexadecimal as well. And through the mnemonics, we understand the machine language. People at the old time used to flip these zeros in one manually. Then the assembly language came in. With the assembly language, it was makes it a lot easier because assembly language had a mnemonics. Mnemonics is just like here. If you put a assembly language. Okay, so assembly language, and I'm going to show you guys. I'm going to put an image of the assembly language. Okay, so this is the assembly language. This is the, say, this is as assembly language. Say it has a value 2. It has a, say for example, if I come here, example, I'm gonna there's a register. You guys can put it back and forth. The register, you guys can flip it. So if I show you the machine language, language, for example. Now if I give you this one, this is machine language. If I give it, does not gonna make sense to you. It does not gonna make sense to you, because it's all zeros and ones. Because the computers understand zeros and ones. Says have a jump. It has a English words. It's called mnemonics. When you convert this one to this one, it's called mnemonics. At the old time, people used to flip these zeros and ones. So 0 0 0 1 makes 1. 0 0 1 1 makes 2. 0 1 0 1 makes it 5. And 0 1 1 1 makes it 6. So that's how you guys count in machine language, but no one's going to understand. This one's very hard to remember the numbers, because, and this is very easy to remember. So you guys going to read, you guys going to jump, you guys going to add, this is called the assembly language. And when we learn Java, you guys needs to know that the assembly language are for, when you program in an assembly language like this, you guys are only programming for one architecture, and that architecture is going to be, say for example, if it's Intel 8085, for example, if it's Intel, the old Intel, if you use machine language to manipulate these zeros and ones here, if you use, say for example, this one, load this one or load this one from this register to that register, if you manipulate this one, that's fine by all means, but you guys gonna build for one architecture. It means you guys gonna put for one specific Intel, whatever Intel you whatever, say for example, if you use machine code for this memory, you guys gonna do it only for this one. It's not gonna be there for another platform. Say Intel is gonna next year gonna bring another one, Intel 8080, then your assembly language here, which you guys already built for one, is not gonna work in that one. So that's a problem, because you guys needs to something, because you guys not gonna every year you guys not gonna start one architecture, one program for every architecture. Say for example, if you, this is the assembly language, this is a very good example. If you have an address, keep in mind this one's got the 4 of these zeros called nibble, and the 8 ones called byte. So 2 of these nibble makes 1 byte, and now from there 1 byte, you guys know how many bytes makes a kilobyte, and how many kilobytes makes a megabyte, and how many megabytes makes a gigabytes, how many gigabytes makes a petabytes, okay, how many gigabytes makes a terabytes. So this 0 0 0, that's how computer started. That's how this is called 0, this is called 1, this is called 2, this is called 3, this is called 4, this is called 5, this is called 6, this is called 5, this is called 6. So here and here we have assembly language. So now you tell me if this one's easier or this one's easier. Which one's easier? I think this one's a lot makes sense, because this one you guys don't need to flip zeros and ones. You guys don't need to do this. You guys, that is called ones complement, that is called twos complement. You guys don't need to do this. You guys gonna come here and write here, load this registry to the ABC to the register, the load this one to this one, 8 this register, they are registered here, the registers of that specific architecture, and here it means that's a halt, finish. So is it easier to do this way or easier to do this way? We as a human understand these words, English words, and it's called mnemonics. Mnemonics are very easy to understand. You guys can interpret this one, you guys can interpret this one as a hexadecimal, and that's beyond the scope of this video, because this video is about Java, and I'm giving you brief introduction about the machine language and the assembly language. So by now you guys should have a very good idea about the computer architecture. You guys should have very good idea about the all the components of the computer, and should have a good idea about the machine code, which is all these zeros and ones, and the assembly language, which we call mnemonics. Say for example, assembly language, this is makes a lot sense than this one, and when you do C and C++, it's going to make a lot sense to do this one, our Java, because C++ are going to work exactly like assembly language. Is going to manipulate all these zeros and one back and forth to different registers and make all the magic of the say programming happen. Say for example, if you come here and do C and C++, C we do versus assembly. So now we're gonna come and see the C versus assembly, and now you guys not gonna tell me now. First we're gonna see that the C assembly language versus machine language. That's a machine language. It's gonna, I guarantee you guys gonna, if I give you to solve some problems, you guys gonna take ages for you guys to solve. And first to begin is very hard, because there's all zeros and ones. It's very hard to remember for you guys. So you guys don't need to know 0 0 is 0, 0 0 0 1 is 1. You guys don't need to know this one. But if I give you the machine, this is a lot easier to understand. This is called mnemonics, because we convert this one to this one. So this one and this one is exactly the same, because this one is going to do exactly the same to machine codes. It doesn't matter if you guys flip this one or if you guys use a software to manipulate that one manually for you guys. But when you guys do manually, it's going to take a lot of people. It's going to take an entire like 50 people to flip all these things, while you can do this one person can do this one like within half an hour or an hour. The same as exactly the same that like used to be at the old times. A lot of people come in and their job was computer. Their job was computer, because they were computing and they're going there flip manually all these zeros one. Then they're working for at that time for NASA. So then the humans programmers come in, decide that look, this is very hard, but this makes it easier, but even this one is very hard. So then we had a C language. And C language, now if you look in here, this is a lot easier, and this one makes sense. So when you come C language, look in here that we have for example, and I'm gonna give you another example here if I can see. So for example, this one in Python, how easy is this? You guys just put it here, print hello world. Our look at this one, this is called syntax of the C, is called hello world. This one's makes it a lot easier for you guys. Our this one's easy, so this one doesn't make sense. It's called to some people, because it's a load. We are loading registry, we are adding, we are storing, we are moving all these bits and pieces to different sectors of the main memory. This one's easier. This one's going to do exactly the same work. It's going to display this hello world. It's going to return 0. It means it's going to return okay. So everything's looking here. This one's plain English. It makes a lot of sense, easier to learn. The learning curve for this one is a lot easier than this guys here. This is a bit very hard, and this is very hard. This is even harder than this. So just to print hello world, you guys need to flip a lot of these zeros and ones back and forth. We can make it to different registry, things like that, to make these things happen, just to computer to say hello world. So back when Apple was invented by Steve Jobs, they sitting in the garage, and just to print one hello world, it took them like about a month, more than a month, just to print this one. Nowadays it's just under the fingerprint, under your fingers, you just type, you just learn a few lines, and that's it, all done. So this is the machine code. Is very hard. This makes it a little bit easier. This makes it even easier. And when it comes to C++, this makes that because that's the C+ with classes, that makes even easier than that. And when it comes to Java, that makes it a lot easier. easier than all of this. But keep in mind the Javas, because Javas are compiled and interpreted language, we're going to do the same ones. We're going to manipulate all these zeros and ones. Every time you guys writing a source code, it automatically goes inside the computer memory and manipulates all this one back and forth. This one gonna move here, there, here, there, here, there. So this assembly language built to manipulate this one machine language, because this one was a bit harder, because this is close to software. It's called low level language. When you guys write C, you guys gonna manipulate the 0, 0 and 1 ones. When the C++ came in, and the C++ is actually C with the classes, it's object oriented part of the C, and Java built on the C++. So now you guys looking the connecting all the dots. So we had this one first, then we had the assembly language, then they came along the C language, then come in C++, and come along the Java. So there is a tree. If you look in here, if you guys connecting the tree, there was a machine language, then there was assembly language, because this makes it a lot easier. Then there was a C++ built on top of C, Java built on top of C++. So Java is written inside the C++, but the main all the programming language, whatever you can see, is going to manipulate all these zeros and one at the low level. So when you hear the low level language, it means we are referring to the languages that are very close to the computer hardware, very close to the computer. Here hardware, this is the hardware computer main memory, because all of the language that we mentioned are through the compiler is gonna compile this one, gonna manipulate this one, is going back and forth, because without this one nothing is gonna happen inside the computer. This is like molecules inside the blood, and when our heart pumps the blood, and it manipulates all these molecules, sending through the blood to different parts of our body. That's exactly Java and C++ and any other programming language, they manipulate this one. But the only exception is that one with the assembly language, you guys can write with one particular platform. With Java, we guys can write for any operating system, regardless of the age, regardless of the platform. Doesn't matter which computer architecture, doesn't matter whichever it is, the Java you guys can write it. So that's what Java makes it unique, and that's why Java is so popular around the world, because you're going to do less work. Being an assembly language is a lot harder, and a lot for you guys is just like impossible. So you guys, every day your boss tells you to go and write assembly language for this particular architecture, and it's going to take you guys ages, months and years to try to figure out how to solve the problem. And even if assembly language is difficult, the machine language is even harder, and even C is a little bit different. But because C by itself doesn't have the classes, it has a classes but it's different form, and C++ offer full object-oriented programming, and Java is already object-oriented programming, so it has a lot of tools, it has a lot of things that you guys can use to make an awesome programming language for every architecture. Alright, so now we have learned the machine language, we have learned the assembly language, we have learned the computer architecture, and in the next video we're gonna show you guys the difference between interpreters and the compilers. Alright, that's it for this video guys. If you have any question or comment, leave in the comment box. Otherwise, I'll see you guys in the next video, and bye.